Semaphores in C#. A semaphore lets you limit the number of concurrent asynchronous threads that can run or access a resource simultaneously. Typically, use of a semaphore can be to limit the number of simultaneous database connections, or to limit the number of threads running concurrently so you don't overburden the CPU or memory usage. You may have only one WebSocket and you want to control the number of threads that use it. With a semaphore, you can limit the number of asynchronous tasks that have access to a resource at the same time. In this example, we set up a semaphore that allows 3 tasks to access the resource at the same time. Tasks will begin filling available semaphore threads. When all 3 of the threads are being used, the next task will have to wait for one of the threads to become available. Once a thread opens, the awaiting task can now be executed. Depending on how long a task takes to complete, threads may become filled again, and tasks will have to wait. As tasks complete, the threads become available. What is important here is that this semaphore will never allow more than 3 tasks to simultaneously access the resource. Other thread controls you may have heard of is lock and mutex. Lock is an older paradigm and generally don't work well with asynchronous processes. It will only allow one thread access to a resource at a time. In an asynchronous paradigm, it is better to use a semaphore with a single thread. A mutex works across multiple processes on a system level. It too limits access for only one thread. Then, of course, there's the semaphore, which can allow more than one asynchronous task in a local process. With that said, let's dive into using semaphores in C#. Here we have a simple C# console application. We create a semaphore slim object. This is a lightweight and faster version of the full semaphore object. Also, we specify that this semaphore will only allow 3 concurrent threads to run. In our main method, we create an array of 5 tasks. Each task will run the access resource method, passing the current task's number to it. With the tasks created, we run and await them all. In the access resource method, all the tasks are queued at the semaphore, waiting for access. Once a thread has access, it will do some work. Here, we just simulated it with a 2-second delay. When it finishes, it must release the semaphore slot so other tasks can be processed by the semaphore. When we run this, we see the 5 tasks queuing up. Notice there's no particular order in which the tasks line up. The semaphore allows the first 3 tasks access and lets them do their work. Once finished, the tasks release their semaphore slots, and the remaining tasks are allowed access by the semaphore. That's all fine and well, but it doesn't give us a true image of what is happening in the semaphore. Because all tasks have the same duration, they are all basically released at the same time. Let's switch things up a bit. We'll give each task a different duration, which we calculate based on the task's number. So, task 3 will delay for 3 seconds, and task 5 for 5 seconds, etc. Now, when we run the app, we get a different picture. 4 tasks line up, and task 2 is granted access, then task 5 joins the queue. Tasks 3 and 4 are granted access, so all 3 slots of the semaphore are filled. Notice again, because these are asynchronous tasks, there's no particular order in which they are processed. Going forward, task 2 releases its slot, and task 1 can now be given access. Task 3 releases its slot, and task 5 now gets an opening. Finally, the tasks finish and all semaphore slots are released. At this point, tasks can wait indefinitely for the semaphore to grant them access. That is fine if you absolutely must process all tasks. But alternatively, you can set a timeout value in the semaphore's wait async method. Here we set the timeout to 1 second. This means if a task or thread does not get a slot in the semaphore within 1 second, it will never enter the semaphore, and the next task in line will get a chance to get access. As you see in line 23, the wait async method can return a bool value to indicate if a task entered the semaphore. If the task is granted access, it is processed and the semaphore slot is released. Otherwise, the task is never processed, and we simply display a message that the thread timed out. Note that we specifically set the timeout value lower than the duration of a thread's process so as to get timeouts. When we run the app, we see threads 1 to 3 lining up. Thread 3 is given access, then thread 5 joins the line. Thread 1 and 2 is also given access, and thread 4 joins the waiting line. Because all semaphore slots are now occupied and busy, threads 4 and 5 times out within 1 second and leaves the waiting line. Finally, the 3 semaphore slots are released. Since we know that our tasks will take around 2 seconds to process, we can increase the timeout value greater than a task's duration so as to ensure more tasks get processed. Now when we run our app again, we see that all 5 tasks were given access and there were 5 releases. What if you don't know the duration of the tasks, but you have to implement a timeout and you want to retry running the tasks that timed out? Now there's many ways to go about doing this, but for our particular solution, we'll add the timeout tasks to a list and try running them again. We start by creating a list that will hold our timeout tasks. Then we place our await all tasks in a loop. We set up a flag that will keep the loop going while there are timeout tasks. In our access resource method, when a task times out, we add it to our list of timeout tasks. Back in our loop, when the await all tasks comes back, it checks if there are any tasks in the timeout tasks list. If so, it sets the loop flag to true, copies the timeout tasks to the task array, and clears the timeout tasks list. This way, the loop is iterated again with the remaining timeout tasks until there's no more tasks and the loop flag is set to false. When we run the app, notice that we still get timeout tasks, but eventually all 5 tasks were granted access and all 5 tasks released their semaphore slots. Let's look at some other features of the semaphore. When defining your semaphore, you can add a second value. This specifies the maximum number of tasks or threads that can be sent to the semaphore concurrently. To use an analogy, imagine a small coffee shop. There may be 30 people waiting to buy coffee, but the small shop can only allow 5 customers inside, and it has 3 counters to serve the customers. As customers get served, the next person can enter the coffee shop and wait in line. We've set up our semaphore to allow a maximum of 5 tasks to wait in line and 3 threads to run simultaneously. But we set up a list of 8 tasks and await them all. Let's see how this runs. Note that as tasks finish, more tasks can enter the semaphore. Eventually, all 8 tasks are granted access. There's one last issue to consider when using semaphores. What if there's an interruption in the process and there are still tasks waiting in the semaphore's wait async? For example, there could be a system shutdown or a user abort, etc. To deal with this, we're going to use a cancellation token. We start by creating a cancellation token source. Then, for demonstration, we'll let it fire off a cancellation after 4 seconds. In line 16, we pass the token to our access resource method when the task is run. Now we use a try-catch block when awaiting our tasks. If the entire operation is canceled, we get a message. Also, in the finally block, we dispose of the cancellation token source. In our access resource method, we accept a cancellation token argument and pass it to our semaphore wait async method. If a cancellation occurs, or any other exception for that matter, we can handle it appropriately. What is important is the finally block. It will check to make sure all threads are released from the semaphore. When we run the app, we can see after 4 seconds, the cancellation token fires off and the waiting tasks are canceled. Thank you for watching our video. For more tutorials on C#, hit subscribe and click the reminder. Give us a like so the video can be visible to more people.